bridge. You walk closer and closer to the edge of the lane, but you will not cross it. You will cross the road because it's exclusive. You will not cross the road because it is exclusive for vehicle. Babike ka, usually as you get closer and closer to the other cyclists or bikers, pero hindi mo sila pwedeng, ang tawag, hindi kayo pwedeng mag-close contact. Why? Kasi ma-aksidente kayo. That idea itself would pertain to limits. Okay? When you move, when you're approaching something, when you are trying to know what happens to the volume, what happens to the area, as you increase the radius, as you increase the volume, what happens to the area of that object, the surface area. Now, these are the questions that would talk about limits. And when we say limits, we always have the term approaching. So, ibig sabihin, when you are approaching something, then limit might exist or will not exist. So, when do limit exist, or when does limit exist, and when does limit not existing? Okay, limit is a mathematical concept based on the idea of closeness. Okay, used primarily to assign values to certain functions at points. Okay, limit, tinan nyo to, behaves, it talks about how a function behaves near a point instead of that point. So there are cases that when you are solving for a limit, there comes time wherein x is not part of the domain of a given function, or a value c is not part of the domain of a given function. However, you're not interested on that case, hence you are looking into how does the function behave as that particular values of x is being used. Okay? So, ang calculus kasi nakafocus yan, no? Backbone niya ay limit. And definitely, ultimately, it is a mathematics of change. Calculus is a mathematics of change. We talk about how quick a particular function changes, okay, at a particular time. So as we go through, mapag-uusapan din natin yung velocity, speed, ganyan. Kasi pinag-uusapan natin kung paano nakaka-apekto ang time sa pagbabago-bago ng velocity, speed, and acceleration. Okay. And how do we study limits? We have different approaches. We have the descriptive, graphical, and numerical. We describe through a graph or through a table. We graph because we talk about function, and when you try to go back to functions, di ba pinag-uusapan din natin dito is how we illustrate functions. We have the tabular, we have the making use of mapping diagram, we make use of table of values and graphs. So with the presence of the graph, when we can actually realize how a function behave. Okay? So katulad nito, nakikita niyo ito sa LMS ninyo. These are the different graphs. We have f of x, that is 2x plus 1, g of x, that is a rational function, and h of x, that is a piecewise function. And at the same time, paano ba sila mag-behave? Makikita nyo dito, okay, at this f of x, ang values ng x na nakikita natin dito, 0, 0.5, 0.8, and it increases, right? X here gets closer and closer to 1, right? Pero, on that case, it gets closer to 1, pero you try to observe saan galing yung values. Is it on the left or the right? When you observe already this value 0.5, 0.8, 0.9, 0.99, these are values which are less than 1. So we can say here, you are approaching 1, but you are referring to left of 1. However, here, you are approaching 1. However, those are the values greater than 1. And then you try to observe that as the values of x gets closer and closer to 1, the values of f of x get closer and closer to 3. Nakikita natin to. Okay, in a tabular presentation, nakikita natin na papalapit ka ng papalapit sa 3 kung gusto mong lapitan. Kung nilalapitan mong x, that is equal to 1, on both sides, ang nangyayari sa f of x ay lumalapit at lumalapit ito sa number 3. Okay? So it means to say that the limit of a function f of x, as x gets closer and closer to 1, then we can say that that is 3 with the use of the table. Okay? In number 2, in a rational function, tandaan niyo hindi niyo pwedeng gamitin ng 2, di ba? Kasi magiging undefined ang g of x. However, when you look into the graph of this function, it is true that it is not possible for us to have x that is equal to 2. However, looking into the graph, graphically, makikita natin na may nilalapitan ang g of x na value, left and right. May nilalapitan silang value at yun ang aalamin natin. Okay? So makikita natin in number 2 that we may not be able to use x that is equal to 2. However, we can say that at the same time, when you do the factoring technique, ay nakakancel ang x minus 2 at nagpapakita ang 2x plus 1. At kapag titignan natin ang g of x at f of x ay pareho na sila. And that is 2x plus 1. And so with g of x. However, class, when you try to go back to the operations on functions, in the division rule of functions, wait for a while. Ay makikita daw natin na yung 2x plus 1 ay magiging the simplified function for g. And yes, it becomes identical to f. However, you will always go back to the original function g and still, walang nagbago, pinagbabawal niya pa rin ng 2. Pero pagdating kasi sa limit of a function, we are always, okay, interested now, we're always interested as to how the given function behaves. Kaya nga kung titignan natin ng function, saan papunta ang value ng g of x as x gets closer and closer to 2. Okay, so naghang yung tanong ngayon. In third problem naman dito, here, h of 1 is equal to 0 because in piecewise function, as you recall, no, x is equal to 1, sabi niya. So, ibig sabihin, use this function. H of x is equal to 0. Therefore, h of 1 is simply 0. However, if x is not equal to 1, kasi for x that is equal to 1, we can make use of h of x that is equal to 0. But when you're now talking about different values of x not equal to 1, then you are going to use this function, which at the same time is equal to f of x. No? And h of x therefore gets closer and closer to 3 as x moves closer also to 1. And when we look back to the graph, nakikita natin na nandito ang h of 1. Because h of 1 is 0. So by plotting, nandyan ang h of 1. By graphing the other function that is 2x plus 1, when x is no longer 1, okay, then we can have a line, and they seems to be they look the same, no? F of x, g of x, h of x. But take note, class, these three functions are not the same. Okay? Because they have their own definition, they have their own restrictions. Okay? So itong tatlong ito ay pinapakilala niya sa iyo kung ano ang nangyayari sa limit of a function habang pareho ang nilalapitan nilang values. You have 1, you have 2. So what happens? That now is the understanding leading to the term limit of a function. So when you consider a function f of a single variable x, then you also consider a constant c which the variable x will approach. So itong c na ito ay yung a number on the domain, a number on the x line, no? Di ba in the xy plane, the horizontal number line, that is the x-axis, okay? Mag-select ka daw doon ng number na lalapitan ng x, okay? That you are trying to approach. And that will lead you to a particular limit which is a unique real value. Itong unique real value which is limit ay ang behavior ng f of x. Ito yung value na pinupuntahan o nilalapitan ng f of x habang ang x ay patuloy sa pagbabago ng values o papalapit ng papalapit siya sa a particular value or real number c. So this is what we call now the representation of limit. And this is read as the limit of f of x as x approaches c is L, where L is a real limit. And let me emphasize again that when L exists, then L is a real number. But when L does not exist, then that L is not a real number. Okay? Kasi dito sa pagsusolve ng limit, iba-iba kasi yung posibilidad. Posible na may real number, posible na may infinity, and posible din does not exist. Okay? And all of this we shall go one by one. Talk about it one by one. Okay, so in the graph of given the function na f of x that is 2x plus 1, sabi niya dito, since the value of 2x plus 1 gets closer and closer to 3 as x gets closer and closer to 1 as proven by the graph, at makikita natin dito na pwede lang pa tayo mag-direct substitution where papalitan natin ang x into 1 at makukuha na natin ng 3. Ganun siya kabilis, no, pag-solve kasi walang ipinagbabawal ang 2x plus 1. Kapag ang function ay walang restriction pagdating sa nire-require niyang values of x, ibig sabihin, kung mag-direct substitution ka daw, ay yun na kaagad ang masosolve mo. At yun ay pinapakita nito, limit of f of x as x approaches 1. Okay? Pero, itong si number 2 naman, pag sinubstitute mo ang x that is equal to 2, magiging undefined ang g of x at x that is equal to 2. However, very strong ang restrictions ito. However, since x approaches 1 and is not equal to 1, let me emphasize this one. Ang ibig sabihin kasi ng approaches, hindi naman daw ibig sabihin na kukunin mo o yung eksaktong value ng C ang lalapitan mo or yun yung pupuntahan mo. Ang rule kasi ng limit is when you are trying to approach a real number 1, for example, then you can have 0.9999990. Ang dami bago mo ma-reach ang 1. Pero sa limit process kasi, hindi daw necessary na yung 1 na yun ay parte ng domain of the given function. Kasi ang gusto mo lang mangyari dito, saan papunta ang value ng function na yan kung lalapitan mo yung x value na yun. Kaya nga, ang nangyari dito is as x approaches 1, sabi niya dito, pwede natin tanggalin ang x minus 2 kasi by factoring technique, matatanggal talaga ang x minus 2 and x minus 2 numerator, denominator, and what's left is 2x plus 1. And you can directly substitute 1 and you will have 3. Okay. Pero dito, class, kapag nagamit yung 2, paano naman kapag you are approaching 2? Go back to the graph. What happens to the limit of this function g when x approaches 2? Ano kaya ang sagot? Kanina, it approaches 1 and the answer is simply 3. What if x approaches 2? Ano ang magiging sagot? May I know? May you please comment your answer in 5 seconds. What do you think is the answer? What is your answer in this case? Okay, bumalik tayo sa graph. When we talk about graphically, no? When we talk about this graphically, ang ibig sabihin kasi nito is what is the limit of g of x as x approaches 2? Saan papunta ang value ng y when you are approaching, when x is approaching 2? Okay, we have here the left. We have here the left limit of g of x as x approaches 2 from the left. We have here the right limit. Okay, let me illustrate them. The limit of g of x as x approaches 2 from the right. Okay, that is the right hand limit. Okay, saan papunta ang what happens to g of x as x approaches 2 from the left? What do you think? Anong value ng y ang nilalapitan, okay, ng function as x approaches 2 from the left? So may you please comment your answer? From the graph, we can see that as x approaches 2 from the left, it gets closer, no? Ang nangyayari kay g of x, it gets closer and closer to 5. However, kay limit of g of x as x approaches 2 from the right, it gets closer and closer to 5 also. Can you see this? There is a hole on the graph. However, nakikita natin dito na pareho sila ng nilalapitan. Okay? Pareho sila ng nilalapitan na value. Okay? Kaya kung makikita ninyo dito, habang dinidecrease mo ang 2, okay, kasi nilalapitan mo dinidecrease mo yung values kasi nilalapitan mo ang 2, or di kaya ay ini-increase mo ang value kasi you want to get closer to 2 from the left, ang mangyayari dito is pareho sila ng tina-target na value of y, and that is equal to 5. Yan ang magiging limit of the given function. So, the limit of g of x as x approaches 2 is equal to 5. Okay, so nandito naman na tayo dito sa left, right, and the two-sided limits. Ang ibig sabihin nito, masasabi natin na pare-pareho ang magiging limits ng left, right, and the two-sided limits if and only if, okay, na-satisfy ang condition na ang left and right, itong left and right na ito ay dapat nag-exist. Ibig sabihin, real numbers sila. And that's true. They are both 5 and that's real number. And they are equal, which is also true because 5 is equal to 5. So when these two limits from left and right are equal, which is 5 and 5, and then at the same time exists because 5 is a real number, then it follows that the two-sided limit here is also equal to 5. Okay, so I guess kailangan na natin pumunta sa rules. Okay, we will now proceed to the rules. However, nasa na yung graphical analysis natin? Okay, before we proceed to the graphical analysis rules, we have the evaluating limits. When we are evaluating limits, you are as well thinking of evaluating function. They seem to be the same. Okay. However, since we are talking about limits, there are some concepts, there are some things you really need to understand because we are referring to limits. We are not evaluating functions. But the evaluation of functions is somehow helpful for you to understand how to get the limit of the given function. And for us to understand, Let's take a look on the different theorems. The first is if limit of f of x as x approaches c exists, then it is a unique. It is unique. So at the same time, it is a real number. Okay? Pagdating naman sa constant, if k is a real number, sabi niya, so limit of a constant k as x approaches c is k. Why? Because that is a constant function. So ibig sabihin nito, whatever happens, whatever happens to x, whatever is the movement of x, nothing will happen on the value of y, and that remains to be k. That's constant. Okay? Third, we have the identity. So this may be thought as a substitution law because x is simply substituted to c. Pero ang ibig sabihin lang naman ng identity ay gayahin mo. Okay? When x approaches c, then ang sagot pa rin ay c. So, what is the limit of x as x approaches 10? So, ang sagot mo pa rin dyan is 10. That is the identity. Pero, kung gusto mo nang mabilisan, so parang substitution lang siya, let x be equal to 10. Here, we have the addition, constant multiple, multiplication, division. Ay, pinaghiwalay mo lang ang dalawang limit problems. Limit terms. So, plus, minus. O di, paghiwalayin mo, you can have plus, and then you can have minus. Okay? So, ganun lang siya kasimple. In constant multiple, ihiwalay mo yung constant k, and then you're going to multiply that to the given function. So if you have limit of 2x as x approaches c, then you will have separate 2, then multiply that to limit of x as x approaches c. So ganun yung ibig sabihin. On the multiplication, that you're going to multiply the two limits, okay, of the two functions. On the division, you divide definitely, pero provided that this should not be 0. So when g of x is equal to 0, may bago na namang rule. Okay? So pag-uusapan lang natin ay ang basic rules. The power rule and nth power, okay, of f of x is also getting the limit of f of x as x approaches c, tapos erase mo siya sa n, and that will be L sub 1 when that is the limit of f of x as x approaches c, raise that to n. Okay? And the root or radical theorem. Kaya dito sa examples, makikita ninyo dito na what is the limit of 5 as x approaches 2? That is simply 5. Why? Because that is constant. Gayahin niya. Okay? So that is a constant rule. For the identity rule, when this is negative 1 and that is simply x, gagayahin niya din. 41, this is also 41. In the constant multiple rule, nakikita natin na there is negative sign here. You may bring it out to follow the constant multiple rule. Pero posible din mag-direct substitution ka, that is negative of negative 1, and that is equal to 1. So here, 3x, so separate constant 3 and multiply that to the limit of x. So nafa-follow niyan, ang limit of x as x approaches 41 already follows the rule of identity. That is why it gives you 3 times 41 is equal to 123. Power rule, okay, you can directly substitute negative 2, erase mo na siya sa 2, then your answer is 4, pwede yun. Or you can have a limit of x, limit of x as x approaches 3 and that is raised to 4, you can have 3 raised to 4 is equal to 81. You can do direct substitution. Addition, radical root, division follows already that way. So parang pag pinahiwalay mo yung limit nitong dalawa, pinaghiwalay siya ng ganyan, and that is subtraction, then you can have 2 minus 5 is equal to negative 3. Why? Because the limit of x as x approaches 2 is simply 2, and limit of 5 as x approaches 2 is negative 5. Okay? Okay, So here, limit of x plus x squared as x approaches negative 3. Pinaghiwalay mo using addition. Kaya we use addition here. And ito, this is already identity function. So that's negative 3. And also identity at the same time is a power rule. So raised to 2. Kaya siya naging negative 3 raised to 2 and that's 9. So negative 3 plus 9 is equal to 6. For radicals naman, beware already of this even index kasi yun yung lagi may problema, even index. Pero pagdating lagi sa mga odd index roots, tulad ng 7th root of negative x, laging may sagot ito. Lagi may sagot basta odd numbered. Walang undefined pagdating sa odd numbered index. Always take note of that. You talk about that in your radical function in general mathematics. Okay? Kaya nga parang simpleng substitution na lang nangyayari, pero ang laging tatandaan ninyo kapag even number ang index ay maraming rules na papasok dito. At yan yung nandun sa week 2 module ninyo. Okay? On the division rule, division simply in the numerator gumamit na siya ng multiplication, no? So when you these are just simple substitutions kung mapapansin ninyo. Ito, kung sinubstitute mo na ngayon ang 3 on the given, tapos ang makukuha mo na is simply 2. Okay? That is as easy when it comes to functions na hindi nangangailangan ng restrictions. Why? Bakit ko nasabing walang restrictions? Kasi itong si 3 naman ay walang kakayahan na gawing undefined yung given functions. Kaya niya bang gawing undefined yan? Well, hindi. However, when x is equal to 1, yun na yung wait lang, hindi ka pwede mag-direct substitution. Bakit? Because x is equal to 1 will make the given function undefined. So in the limit process, pag undefined ang isang function at a given x, in the limit process, ang mangyayari is mayroong mga rules na posibleng magpakita at yun ang pag-aaralan natin as we go through. So ang week 1 nyo lang naman is more on basic concepts lang. So don't worry at this moment because you are still starting. Okay. So here, ayan ang sinasabi ko, when n is odd, then you can have all numbers, all limits always real and always existing. No problem to odd number. Kahit ano man yan, lagi siyang mag-exist. And you can do direct substitution sa kanya, no problem for odd numbers. Okay? So dito naman, in this case, evaluating the function at a given x. O, yan siya. O, can you see that? That is now what I'm referring to be direct substitution on most cases. Okay. Wait lang, bakit nawala ang ating So that is direct substitution. Let f be a function if c is in the domain of f. Or should I say, c is not the cause of restrictions. Then ang mangyayari ay pwede lang daw kayo mag-direct substitution. Lagi nyo lang tatandaan, class, na ang laging may restrictions ay radical functions, rational functions. Ang walang restriction sa ganito is we have the polynomial functions. All polynomial functions does not have any restrictions at all. Kaya ang mangyayari is you can have direct substitution always. Okay? Pero kapag nakalampas ka sa restrictions, katulad nitong number 1, that is simply a linear function, direct substitution can do. Number 2 is quadratic, direct substitution. Number 3 is a radical function, but this is negative 2. Hindi siya critical, no? Kasi negative 2 plus 11 is 9, and that's positive. So that's accepted. Hindi siya critical. You can do direct substitution. Number 4, ang negative 3 naman, hindi niya gagawing 0 ang denominator. So direct substitution. Number 5, 2 does not make x minus 1 0. So this is direct substitution. Okay. So ito na yung sinasabi ko kanina class sa inyo. We have the one-sided limits. Kanina, okay? So ang mga ito, pinag-usapan natin kung paano ang pagkuha ng limits. You can do direct substitutions. All the rules can be applied. However, there are possible cases wherein we need to know the one-sided limits. So in a one-sided limits, we need to take note of the left and right. Lalo na ito, okay, very applicable ito class sa mga may restrictions. Tulad ng piecewise functions, radical functions, rational functions. Paano daw kapag napunta ka dun sa mga may mga restrictions? Dito na papasok ang left and right limits at saka ang two-sided limits. The one-sided limits ay itong dalawa. We have the left and the other is right. Ito naman, we call this one as the two-sided limits. Ang two-sided limits, nire-require niya ang left and right, okay? Para mag-exist ang two-sided limits, nire-require niya ang left and right na mag-exist at pareho sila. So when left and right do not exist and they are not equal, ultimately not equal, then the limit of the given function is not existing at the same time. Kaya ito nga, sabi niya, di ba? Whenever limit of f of x as x approaches c from the left, this one is from the left because of negative sign, and the limit of f of x as x approaches c from the right, not existing, they are not equal. So pag sinabi mo nang hindi sila equal, ibig sabihin hindi na talaga sila nag-exist. Hindi nag-exist yung two-sided limits. But there are possible cases wherein left exists, right do not exist, or pareho silang nag-exist pero hindi sila equal. Now those are the cases wherein that will make the limit of the given function not existing. At yun ay mas ma-appreciate nyo siya pag pinag-usapan na natin ang graphical analysis. On the graphical analysis of limits kasi class, we really need to take note of the left and right. After knowing that the domain of polynomial functions is a set of real numbers, for whatever is the polynomial function, you can enjoy solving all. Direct substitution is done and no problem at all. Pero pagdating ng mga functions na may mga restrictions, yun na yung sinasabi natin, you have to take a look into how does left behave, how does right behave, and combine them together for you to know what is the limit, the two-sided limits. So katulad dito, f of x is equal to 2x plus 1, that is simply a linear function. So no problem at all. Kasi kapag you are solving for the limit as x approaches 1 from the left and x approaches 1 from the right, direct substitution can now be applied. So 2 times 1 plus 1, that is equal to 3. And so with the right, that is equal to 3. So it is now confirming that the two-sided limits is simply 3 because they are equal. Kailangan equal ang left at right at kailangan nag-exist sila bago mo masabi na ang two-sided limit ay nag-exist at siya din mismo yung value na na-solve mo. So kung 3 ang left, 3 ang right, 3 din dapat ang two-sided limits. Okay? But here, on the other example na pinag-usapan natin kanina, okay, kung mapapansin natin graphically, okay, nag-move ito. Sorry, nag-move ito. That must be here. Okay. You see, from the left of 2, x approaches negative 2 from the left, the answer is 5. From the right, the answer is also 5. Well, graphically speaking, nakikita natin na sa 5 papunta ang values ng y. Graphically. So, when you are approaching 2 from the left or approaching 2 from the right, graphically speaking, y gets closer to 5. Okay? Pero how are you going to solve this one with the absence of the graph? With the absence of the graph, ang mangyayari dyan, you can do, okay, the what we call the factoring technique na pinakita kanina. If you're going to factor out 2x squared minus 3x minus 2, bring out x minus 2, and you have x minus 2 here, para makancel mo siya. Ano yung natira? Di ba we have 2x plus 1? Yun ang natira. So we cancel this. Para mangyari, from 2x plus 1, palitan mo ang x ng 2. So you have 2 times 2 plus 1. The answer is 5. So ibig sabihin, left and right will now give you 5 as proven. Graphically and with the use of the equation, they both share the same answer. With the graph, the answer is 5. With the function, the answer is also 5. Plus, hindi mo pwedeng hindi tanggalin. May I repeat? Hindi pwedeng hindi tanggalin ang x minus 2 na denominator, especially kung mag-direct substitution ka. Why? Kasi there are cases wherein wala yung graph. So, paano kung wala ang graph at tapos ang given na lang ay isang function? At sinubstitute mo ang 2 dyan kasi, sir, sabi mo, i-substitute. So, anong mangyayari? Magiging undefined to. Pero para matanggal ang undefined na yan, okay, or what I mean here is para ma-remove ang x minus 2, kailangan kang mag-factor out so that you can have 2x plus 1. And from 2x plus 1, palitan mo yan ng 2, ang x, then it will give you 5. Okay? Nasaan yung isa? And from the graph of h of x, yung pinaka-intro kanina, graphically speaking, as x approaches 1, oh, bakit 2 ito ang nilagay ko? This must be 1. So let me correct that. This must be 1. So as x approaches 1 from the left and x approaches 1 from the right, then you will have now an answer that is equal to 3. Graphically speaking, papunta ang values ng y from, okay, let me papunta yung values ng y sa 3, okay? Ang ibig sabihin kasi ng x that is equal to 1, yung sa domain na x that is equal to 1, tanging si h of x that is equal to 0 ang nagmamay-ari lang doon. Kaya isa lang siyang point. It is a single. Okay? Whenever you encounter x is equal to 1, you are just referring to a unit set. Only one in the elements of the domain is being contained by h of x that is equal to 0. All other real numbers are now contained by 2x plus 1. Kaya makikita ninyo sa graph na lahat, ito na buo ang graph na ito kasi ang ibig sabihin, lahat ng values ng x na hindi 1 ay pagmamay-ari na ni 2x plus 1. All of them. And what happens to the graph? Okay, papunta siya sa number na 3. And the graph also tells you it happens that way, graphically. Kasi nakikita mo ang movement ng graph na ito pagdating sa y. Can you see the movement? Di ba papunta siya sa 3? And so with the right, it gets closer to 3. Kaya ang limit is equal to 3. That is the real number na pinupuntahan ng h of x habang ang x ay papalapit ng papalapit sa 1 on both sides. Okay? So this must be 1. I need to correct this 1 sa LMS. Okay. Remember that 1 is not in the domain of h. Actually, kapag but this does not mean that the limit does not exist. Kasi even though it happens that way, still there is an answer that is equal to 3. Kasi sabi nga natin, pagdating sa limit, ang pinag-uusapan lang natin dito ay kung paano mag-behave yung function habang nagpapalit ang values ng x. Okay? So I think we have to take a look on this case. Kasi isa ito sa tingin ko ay nalilito ang karamihan when they are reading this part of the lesson. Ang sabi dito, if f of x approaches 0 from the left as x approaches c. left ito. So, ibig sabihin, you are referring to negative numbers. Di ba ang left ng 0 ay negative numbers? You can have negative 0.001, negative 0.0009. These are the numbers on the left of 0 and these are, okay, tingnan natin ang condition. Tapos, yung n daw is even. O tandaan ninyo, di ba pinagbabawal ng even index na radical function ang negative na radicand? So sa madaling salita, pag nangyari daw yun na ang f of x na ito, ang limit niya ay papalapit or nasa left of 0 and this is a negative number, then definitely the limit of the given function does not exist. Can you get the idea there? Saint Anselm, can you get the idea there? That when you keep on, when that f of x gets closer and closer to 0, but that is on the left of 0. So you are referring to all negative numbers very close to 0. As x approaches c, tapos ang n pa ay even number. So ang pwede mo daw sabihin dito, the limit does not exist. You try to look into this one, the first example. Alam natin, no, or alam ninyo na ang domain ng isang function na given ay ayan. Ang kanyang domain is negative infinity to 3, include 3. Union 4 to positive infinity, include 4. Okay. Ang ibig sabihin nito, in the number line therefore, kung ito ang 3 at ito ang 4, ang pwede lang daw sa kanya ay lahat ng numbers less than 3 at lahat ng numbers less than or equal to 3 and all numbers greater than or equal to 4. Sa madaling salita, paano ko ang nangyari is you are referring to the left of 4? Di ba nakikita natin that on the left of 4, sa left ng 4, ito ang left ng 4. Left of 4, this is right of 4. However, left of 3, this is right of 3. Nakikita natin na kapag pinag-usapan mo dito ay left of 4, ay nawawala ang graph. At kapag tinignan mo yung right of 3, nawawala din ang graph. Bakit? Because you don't see any point that is very close to 3 on its right. Kaya itong number 1 na ito, nakikita natin that the limit of square root of x minus 3 times x minus 4 as x approaches 3 from the right does not exist. At ano ang naging dahilan? Pag sinubstitute mo ang 3 dito sa x minus 3, at alam mo naman, aminado ka naman na ang lahat ng numbers na mas malaki sa 3 ay laging bibigyan niya si x minus 3 ng positive. Tama? Kasi kung meron kang 3.1111, i-minus mo sa 3, hindi 0. Kaya ang nangyari dito is right of 0. Ang ibig sabihin ng right of 0 ay numbers greater than 0 but almost 0. At i-multiply mo yan sa negative 1. Okay. Bakit negative yan, sir? That might be your question. Kasi tingnan nyo ito, class. On the right of 3, sabi niya. And when you are referring to the numbers very close to 3 from its right, these are the numbers na mas maliit pa sa 4. Ang 3.111, i-minus mo sa 4. Ang 3.2, i-minus mo sa 4. 3.0002, i-minus mo sa 4. Anong number ang pinakamalapit sa... Ano ang number na halos yun ang pinakamalapit na difference, because that is subtraction, when you keep on using numbers very close to 3 from the right. 1. And when you have a number that is positive, kasi this this right of 0 meaning that is a positive number, and when you apply that to negative 1, what happens? Di ba ang laging lalabas ay a negative number that is almost 0 or left of 0 but almost 0? That is the reason why the limit does not exist. And the graph can support you that. Kasi kung titignan mo sa graph, ito yung right of 3. Anong nakikita natin? Can we see any graph here? Can we see? Is there a connection? Nag-connect ba? Di ba wala? So, sabihin, ang limit ng function na yan does not exist at right of 3. Paano naman sa left of 4? Sa left of 4, makikita natin na when you keep on using, when you keep on so 4, less than 4 kasi left of 4, but almost 4, ang magpapakita na magiging solution for x minus 3 ay mas malaki sa 1. Okay? It is very close to 1 on that. Okay? Na, however, this x minus 4 here becomes negative. Bakit? Kasi left of 4, dito sa left of 4, ang sinasabi niya is, these are the numbers less than 4. Okay? These are the numbers less than 4. However, that is negative 4. So, can you imagine this one? 3.99 minus 4. Hindi ba you're almost approaching 0, but that will always be negative. Kaya nga sinasabi nito, negative. Left of 0. Negative ang nagpapakita na solution daw dyan. So, ibig sabihin, square root of a negative number is still undefined when it comes to evaluating function. And when it comes to the limit process, magiging undefined yan. Bakit? Kasi ang literal na ibig sabihin nito, walang graph sa left of 4. Kasi nakat siya dito, oh. Yun, sabi niya. Ibig sabihin, 3 and 4. Nakat na siya sa 3 at 4. So lahat ng numbers sa pagitan ng 3 at 4, pag ginamit mo daw sila, ang limit ng function na yan will always not existing. Okay? Di ba yung nasa right ng 3 ay numbers between 3 and 4? Ang nasa left ng 4 ay numbers between 3 and 4. These numbers are not part of the domain and they are ultimately naging yun yung parang na-chop siya doon. 3 and 4 lang kasi. So ang dami pang numbers between them. Nakat na doon. So ibig sabihin, hindi na mag-exist ang limit between them. Okay? Tingnan nyo naman ito, si 7 over 2. Si 7 over 2 is, that is half of 7 and that is 3.5. Dito si 3.5 sa gitna, sa pagitan ng 3 at 4, si 3.5, right? So ibig sabihin, the more na hindi siya mag-exist, kasi kahit hindi yung master class, kahit hindi nyo i-master itong symbolic na ito, symbolic representations na mga ganito, mo yung domain rule ng radical function, kitang-kita mo kaagad kung bakit siya undefined. Why? Kasi sa pagitan ng 3, sabi niya, sa pagitan ng 3 at 4, bawal na lahat yun. So ibig sabihin, what will happen here? Then all of the numbers you're there, when you are selecting a number between 3 and 4, na the limit does not exist na. Okay? Kasi wala na siyang graph on that part. Am I clear on that? O nalilito pa rin kayo? Saint Anselm, am I clear on that? Kasi yung part na yan talaga for sure, graphically ay marami ang malilito pag binasa nila. Pero saan dyan ang at ano yung sa tingin nyo ay dapat kong i-clarify? Saint Anselm. May I know?